Hi guys. So just a quick question. Do you have an estimate of how many accidents occur just in the US every single year? 10 million. 10 million. Any other guess? 5 million. 10,000. Seems like you guys have been reading the news. So the estimate number is about 6 to 7 million accidents on the road every single year, and that's just in the US. It's really a surprising statistic, isn't it? So that is one of the reasons why I and my friends in my undergrad back in 2019 decided to work on this system called as the intelligent accident avoiding system. But let's look at some stats that tells us why do we need this kind of a system. So just in the US, in the year of 2022, there are up to 290 million trucks and cars on the road, and that number I don't see that decreasing. The graph is increasing year by year. And what increases with the number of cars on the road? Obviously, the accidents that occur. It's up to 7.27 million just in 2022. So it's a huge problem that we need to solve, right? So I have a video for you to see. Let's have a look at that. It's surprising, isn't it? So there is an imminent need of accident avoiding systems. So this video really shocked me and my teammates, and we decided to work on this project. So here are some of the goals that we decided for this one. So the first one is, of course, reducing, if not avoiding, passenger safety. So human life is really precious, and we need to save it. So that is the obvious goal that we have. The second one is that we need to ensure that there is a braking application. You saw in the video that guy, I calculated it, that guy had about 0.2 seconds to react. We blink in 0.3 seconds. So it's almost impossible for a human to react in such a short amount of time. So we need a braking application for sure in these kind of situations, and humans can do it. So we need a system in place. And the third one is, even if we do get sometimes in some scenarios, we don't have enough of it. So even if there is a braking application, we don't have it enough. So we need something that can be that can apply brakes very quickly. The response time has to be decreased. And the last one is that we do have some accident avoiding systems in place, namely airbags and seat belts that can save lives, but we are relying too much on them. How about one more system that can help us increase the safety? So these are some of the parts that we used in our project. I can tell you about the intricacies of these parts, but if I start doing it, I'm sure that you're going to get the best sleep of your life. So I don't want that right now. So there are two systems on which this entire system was designed. The first one was automatic braking system. So as I said, we need a braking application. So the automatic braking system just stops the vehicle when it senses there's going to be an accident. And the second one was the pneumatic bumper system. So the bumper is this kind of a thing, this kind of a rod that comes on the front part of the vehicle. It's made up of shock absorbing material. So this is something that protrudes out whenever whenever it detects that there is going to be an accident, and it shocks and it absorbs the shocks so that it does not mediate to the passengers, and it saves the aesthetics of the car as well. And this is the kind of prototype that we built. We manufactured it ourselves. We had tons of fun and learning while doing this. So you can see that we have a wheel there that spins. It has a DC motor attached to it. And whenever there is something that comes in front of the vehicle, it detects that and it pushes out the bumpers so as to absorb any shock in case there is going to be a crash. And it also simultaneously stops the wheels. So there is an automatic braking system in place. So you might be wondering, how does it all work in unison? So I'll just show you quickly. So there is an ultrasonic sensor, and there is the brains of the computer. So there is the microcontroller. It was an Arduino Uno microcontroller that we used. And now there comes an external object. So this external object is in the proximity of that ultrasonic sensor. So the sensor detects it and it says, Mayday, Mayday, Mayday. There is something in front of the vehicle that we don't want. It sends a signal back to the microcontroller that there is going to be a crash. The microcontroller then sends a signal to the solenoid valves. The solenoid valves, think of it like a tap. So whenever it gets some electrical signals, it just opens up and it allows the flow of substances. In this case, we use compressed air. So compressed air is now being allowed to go through the solenoid valves to the two pneumatic cylinders. Pneumatic cylinders are just small cylinder type things, so they have a rod inside them. But whenever they get compressed air, the rod just comes out, and whenever they don't, it goes back in. So when these pneumatic cylinders, they get compressed air from the solenoid valves. And these pneumatic cylinders then activate the braking system and the bumper system simultaneously. So your car stops and there is the bumper that comes outside. So I'm sure that you want to see it in action. Pretty neat, isn't it? So this is how the system worked. You saw that guy placing his hand in front of the sensor and stops the wheel, and also the bumper comes out. So this goes to show that if we collaborate with our different technical backgrounds, I had an electronics engineer, I was mechanical engineering myself. So we collaborated and we came up with this kind of a system. So in this room, we are coming from different technical backgrounds. If we collaborate together and put these systems in place, we can create a great impact. We can save lives. And this is something that Elon Musk did a couple of years ago. He built self-driving cars. There was an incident where a cyclist got hit by a Tesla because the driver slept and that cyclist was killed. So that's why he started making these self-driving cars, and now we have cars that literally drive themselves. And in this graph, it is pretty apparent that a car with self-driving has to drive about 5 to 6 million miles to meet an accident, whereas the car with that does not have any self-driving capacity will meet an accident in about 500 million miles. So that's the kind of impact that we have today. Thank you so much.
Thank you.